See the quotient property of square roots. Notice how if you have a fraction underneath the square root, you can split it into two separate radicals with the fraction bar in between. Notice though that we do not like having radicals in the denominator. It's a no-no. But notice first here that we can split these up. Okay, so keep that in mind. So we have what's called rationalizing the denominator, and this is a skill that's still taught, but you want to rationalize whether it's in the denominator or in the numerator. It doesn't matter, it's just a skill you should know how to do. So what that means is we're going to not have a radical in the denominator. So how can we possibly get rid of that radical 11? If we multiply it by itself, we get radical 121, which if we do that to the denominator, we need to do that to the numerator too. So that's going to turn into 6 rad 11 over rad 121. Well, what's the square root of 121? 11. So here is our new form. And notice the 6 and the 11 cannot be simplified, but this is now rationalizing the denominator. There are multiple ways of showing how to rationalize or how to simplify. So this is just one approach. If you have a chance to simplify the fraction, start there. All right, so now we're going to split the numerator and the denominator, and now we can rationalize by doing what I did over here. I need to multiply this by itself, but to keep the fraction equivalent, you have to also multiply by the same number on the top. Notice we're multiplying by 1. Little hint into equivalent fractions. So this is going to turn into rad 49, but the square root of 49 is still going to be a 7. So that's how I get rid of that. Remember, this becomes rad 49, but it's just a 7. Rad 2 times rad 7 is rad 14. Do you have a perfect square inside of 14? No, because that number is composed of just factors 2 and 7 or 1 and 14. This is my answer. On number 10, you can see I split the numbers on this side, and I'm trying to think of numbers that is a perfect square for a factor of 80. But then look at the variables over here. So is there something you can simplify here? I hope you can recognize that y cubed divided by y cubed is just 1. X squared divided by 1x, well, it divides one of them out. So now you're left with radical x, but it's going to be in the numerator. So that means that we're only going to have to worry about the number part. So I have to tell you that I like this part because you have to simplify it and it's just about adding. So notice they have different radicals. These are not like radicals. Just like anything that we've practiced, when we add or subtract, they have to be like terms. So in this case, the 3 is the same, but they're not the same kind. So what we're going to do is we're going to simplify the radicals. So what perfect square goes inside of 8? I hope you can see it's a 4 times a rad 2. So rad 4 times rad 2 is rad 8. Now remember, there's a 3 on the outside, so that's also multiplying. So now we have 3 times rad 4 becomes a 2 times rad 2. So this is now 6 rad 2. And now you can bring this other stuff down. And now notice we have the same radicals, but we add their coefficient there. Well, it's not a coefficient, but it's the multiplier. There's 6 times rad 2. There's 3 times rad 2. So how many rad 2s do we have altogether? There's 9 rad 2s. So that's my answer right there. When we look at 15, similar situations. Notice here this has a 5, so I'm thinking this is the one that's going to get broken down. But let's see what happens to the 18. So 18 can be broken down into rad 9 times rad 2. Notice I always start with the perfect square because that's what's going to get broken down. There was a 2 to begin with, so don't forget that. So this is going to turn into 2 times 3 times rad 2, or 6 rad 2. The middle one, notice there's a minus, so I'm just going to put a minus 2 right here. This can be broken down into rad 4 times rad 5. So when I do the math here, this is negative 2 times rad 5 minus 4 rad 5. And the last piece is going to be this one, which really, there's nothing to simplify. So now that we look at all of the parts, this has a radical 2, this is a radical 5, this has a radical 5. So the only things that we can put together are these two. So negative 4 rad 5 minus a 2 rad 5, well, they're both negative, so we're going to have more negative rad 5s. So we're going to have negative 6 rad 5s, and now this just gets brought down. That's it. Don't overcomplicate this. Just be aware. You're going to see more of it later on in the next grade level. All right, number 16. So I see 4, radical 4 times radical 3. Don't forget the 3 at the front. So that's going to be 3 times 2 times radical 3, or 6 radical 3. The middle portion is 3. I hope you can see the 9 times the 2. So that's going to turn into 3 times rad 2, or 9 rad 2. And the last one, let's see, there is a plus 2. I see a 9 times a 3 plus 2 rad 3. Oop, oh, mistake. Hold on. We can fix it. Times 3 times radical 3. There we go. So this turns into 6 radical 3. So now, what can we put together? The rad 3 and the rad 3, notice they both have the same number in the front, same multiplier. So we're going to have 12 radical 3s plus 9 radical 2. And that's our answer. I love this stuff. I hope you enjoy it.
But would you take me seriously? Oh, Bucky's participating. Yes! He wasn't participating earlier. He's finally participating. Somebody in class is participating. Yo, Bucky!